ahead. So, I'm not trying to say that these sections we've been doing are easy, but what they are is definitely easier than some of the other ones that we're going to run into. And so it's just a case of, I don't wanna waste too much time on the ones that are very doable. Not that they're easy, but they're very doable. And I would like to be able to save some time for the other ones that I know historically have slowed down students. So like when we get to Unit 8, not the beginning of 8, but basically the last 3-ish sections or so, they're kind of all the same topic. They're all about volume. So it's volume of shapes that aren't, regular straight lines. And it's all the functions that we're dealing with, but 3-dimensional. And so that's generally where students have had a really hard time trying to visualize them, trying to draw them. And so I would definitely like to move through the doable sections now so that I certainly can slow down, help you guys learn how to draw them, how to visualize them. I even have some models that students have made in the past that help visualize them, so. So that's why I'm kind of pushing through right now. Like I most definitely don't like the feeling of just kind of moving on, right? Like I don't even know how many of you are done with the homework for 7.1 yet. And I don't want to ask because I don't want to actually know quite now. But 7.3, again, it's not going to be easy, but it's going to be definitely doable. And once you see what you're supposed to do with them, it's not so bad. It's not so scary. It's actually pretty much exactly like everything we have been doing. So the differential equations, most of the ones we've gotten so far, like A and B, like they're written something like that. And there is a way to find the general solution, like we're going to integrate to find the answer, but I haven't really gone over how you have to approach that. Actually, let me back up. Remember the slope field we drew and I put up on the board from Desmos? Yes, I drew the particular solution wrong. I don't know why I was pointing at that, but that was like in my brain, I was visualizing it and pointing at it. I drew it wrong only because the random point that, I can't remember who picked it, but the random point that we chose was very close to the border for where the graph splits. I kind of feel like I want to at least show you that one. Son of a gun. Oh, I threw away the Post-it. Oh, I'm not gonna try that. Oh, girls. Somebody threw their whole Starbucks in there, that's awesome. Let me put Desmos back up. There it is. And I believe that was even the example one, so that works out perfect. So we had chosen 1, 1. Come on. It was being very glitchy and slow yesterday too, there we go. Okay. So we had chosen 1, 1 yesterday, and if I remember correctly, I basically drew a parabola. Okay? If we had chosen a point above 1, 1, I don't know if I'm gonna be able to do this. I'm supposed to be able to write on top of it, but whatever. If we had chosen a point above 1, 1, this would have worked. Okay, well, that works good enough. But 1, 1 was low enough that this slope that's aiming and pointing wouldn't actually hit the y-axis, because y-axis had slopes of 0. The x-axis had undefined slopes that were going straight up and down. So what would have actually happened is at 1, 1, I would have had a essentially a sideways parabola. And so I had graphed our differential equation later in the day for the 6th-hour class. I just typed it in here. I don't know why I didn't think of that during 2nd hour. And then that's when I realized and found out it is actually on that side. So it was just kind of pure chance that the particular solution we had chosen was kind of right between the border of where it would switch from parabola-like to sideways parabola-like. Anyway, it bothered me that I drew the wrong one, so I wanted to show you the correct one. In fact, I suppose I can just type it in. I semi-remember it. It was 1/2 y squared minus x squared equals, I think, 0.5? Nope. So that was, if it was slightly higher, so even like 1.5, made parabola like, one of these must have been different. So I would get 1/2 y squared, 1x squared. Oh, this must be a different number here. Oh, it was negative 0.5, I bet. Yeah. So going through 1, made it go on the side instead of right above it, whereas the point right here would have been a parabola. I guess it bothered me. It probably didn't bother you one bit. If you're going to be asked to draw a particular solution, I can't imagine they would give you a point that would be so close that you would have to guess whether it went straight down or whether it went across. Ours was just pure chance that our point that we chose was right on the border where it switches. Okay, nothing to do with today's. Just bothered me. Bothered me that I drew it wrong yesterday for you guys. Okay. Grading. Who are you going to choose? Owen? Did you choose it the last couple times? That was somebody else that picked your mind. Oh, all right. I was going to say, I was going to have you choose somebody because you feel like you've done every day. You have replaced Matt as the daily answer.
Yeah, we need to get that.
Oh, wait a minute. Let's just go back to tradition.
Yeah, of course.
Okay, Matt. When we integrate something, we haven't really, we've talked a little bit about it, but let's say we're integrating x squared. What would have to be at the end for us to be able to integrate x squared correctly?
Yes.
Okay, and if this was a y squared, we would have to have dy, correct. So whenever you're integrating something, it has to have the correct information following it. Well, the easy answer to finding a general solution is you integrate. But this doesn't really work, for one, because, well, this example has two variables, but it is missing the portion at the end that we need to be able to integrate. And so separation of variables is a method that we just basically take apart the notation for derivative, dy dx. We've been using it all year. It can be taken apart and pieces. So if I multiply both sides by dx, then this would say dy equals 2x over y dx. Now, I still can't integrate both sides because that y is there. It has to be one variable to be able to integrate until you get to Calc 3, and then they teach you two variables. So we can do normal operations, but basically only multiplication and division. We can't do addition and subtraction because that wouldn't work with the way that the integration notation is set up. So we can multiply both sides by y, And then the information we have is correctly grouped, where if we were to integrate both sides of the equation, both sides would work. Now, this is the example we had yesterday. This is the one we grabbed. And then integrating y is like y to the first, so you would get 1/2 y squared equals the integral of 2x is x squared. And then just like when we did integration before, you don't have to have multiple plus c's. You could just put a single plus c somewhere. So you could choose wherever you want to put the plus c. And this is essentially what I had just typed into Desmos to graph for you guys, a particular solution. But when we chose to put 1, 1, I used the point 1, 1 to calculate what c would have been. And for our example yesterday, c would have been negative 0.5. But the big take out of this problem, to be able to integrate both sides to find a general solution, you have to rearrange all variables so that they line up and match up. How about B? I don't think I have, oh yeah, I did have you answer. Now we'll go back to one. Do I have to do anything on this one? No, actually, let me rephrase the question. Why are we guaranteed y's will be on the left-hand side, x's will be on the right-hand side? So the way that dy dx is written.
The dx is on the bottom.
Correct. And all of our dx's, our dy's have to be essentially on the top of a fraction or multiplied. So if you have a dx being divided, you're guaranteeing that we have to multiply by it and it will put it on the other side. So then, Owen, I don't know if you want to answer this or you want somebody else to answer this. Can we do this problem currently?
No.
No, because?
Because the dx and dy are on
Yeah,
the wrong side.
yeah, they're not arranged together correctly. So even if the problem's gonna look terrible, you still need to arrange the information accordingly. All right, thanks. Okay, choose somebody.
Spencer.
What should I do if I want to get the y squared on the left? I can't just subtract, right? Okay. So we basically can only use multiplication and division. Okay. So now this is gonna read, it doesn't actually matter how I write it. I most certainly can write 1 over y squared times dy. So, like if you like the dy at, if you like the dy at the end of the problem, you can always write it however you like. Okay, well, I have information accordingly moved. So if I integrate, now I gotta figure out what I'm gonna get. I don't know, rather than like choose, like having you guys choose somebody, is there anybody that thinks they know what the answers should be?
For the y one, isn't that just du over u, so it'd be natural log?
No,
It feels like it should be, but it's not,
isn't it just one?
because the derivative would be 2y.
Oh, yeah.
One over one.
So say again?
No, one over one.
For a natural log, yes. This isn't natural log. Oh, were you trying to say something different then?
But like that's the answer, isn't
No.
Could you bring up the y squared as
Yes.
y negative 2?
Yep. So this one's just, is that what you were trying to say?
it? Yeah, so it's the, like that.
You were trying to tell me the answer was 1 over y. I thought you were trying to carry on Donald's
No.
suggestion. I understand
Yeah,
now.
now I'm confused.
Okay, so the y squared on the bottom is the same thing as y to the negative 2. And you can just straight use power rule to that one. So I'm gonna add 1 to negative 2 power. Dang it. Gonna add 1 to the negative 2 power, and you would get y to the negative 1. And then you will divide by the negative 1. And then, how about the integral of dx? That's actually the one that's gonna stuff most people.
X.
It's just x, yeah. So you're integrating one. When there's no number, when there's nothing shown, it's a one. So integrating one would be one x. And, in my opinion, there's no correct way that this would have to be written. Where I find it annoying on the AP test is they sometimes feel that one form is a more correct way to write something. So I wouldn't be terribly shocked if they would somehow rewrite this so that there was no fractions, right? So like multiply both sides by y or something, I don't know.
I just had a question, isn't dy just the derivative of y?
Yep.
So, is that just the derivative of y itself, or of?
Correct.
Of y squared?
Nope, just of y.
Just of y.
Yep.
Okay.
So if you had one y, dy is the derivative of one y.
Okay.
That's kind of what you're asking?
Yes.
Yep.
What do you mean by that? What do you mean by them rewriting?
So this one could be written as -1/y equals x plus c. And it's possible they would consider the y being in the denominator incorrect. Like if you were trying to solve the equation for y equals, like somewhat function format.
If this was like an FIQ question, and they, you don't know.
Would not matter one bit.
Okay.
Yep. My guess is if this was an FRQ question, they would also give you numbers to put in, so it wouldn't matter at all how we read it.
Why is y like negative, or like why is?
So if I divide by the -1
Oh yeah.
from the new power, I could just write a negative symbol. Where this section is gonna become difficult, more difficult, is not the idea. The idea is you just move things around so the letters are grouped. That's literally what the separation of variables means. It means you separate the variables so they're grouped together alike. The integration and the solving for C can get iffy. I feel like that's not gonna be terribly different than the other one. The answer would be, we got time. We got time. I planned, up till Thursday for this. And if you look through the notes, there's actually not many pages of notes. This section is just a ton of examples. There's not really much for explanation of things because they're all the same idea. So I was going to skip this one, but no need, like, we have time for it. I built time for this. Do you guys feel like you should be able to try that on your own, most likely though? This one's semi-straightforward. Try this one on your own. And actually, let's give you a little added difficulty. I mean, why not? You guys are smart.
What's T?
What? T?
Fiction sucks.
Solve for y at the end.
Oh, that's fine.
What'd you say about T?
Huh?
What'd you
No,
say
my
about?
vision just sucks. I don't know.
Oh, okay.
It's not a T, it's what's that called again?
Now it is.
No.
Oh, asterisk.
Asterisk.
The star, asterisk.
Yeah.
Wasn't there this one cartoon character named Asterix? Yeah. The one about like the gall.
I have no
Oh,
idea what
wait,
you're talking
oh,
about.
damn it, now I.
That's probably a cartoon I don't know though.
How do you get rid of an LIC? Oh, this is solved for y?
Wait, isn't there?
Oh, that's a good question.
I don't know. I spent like.
You
long in
did,
natural
you've
law.
done a lot of this in pre-calc.
And then never talked about natural law again.
How did you solve natural law?
Yeah, how do you even get?
E to the power, like what your, the other side.
Or a number to the power.
Yeah. Well, that sounds like a good idea.
Like if the other side is like ten,
Why
or
that
like
would
ln of
get
x,
rid of the
take
natural
it to the 10.
So multiply both sides.
So most of you did the integration really quickly. It's the solving for y that's not great?
Yeah.
Okay, good. I mean, that's a good sign though. The solving for y, I kinda just threw that on you because you're gonna have to do that. So, why don't I put at least the integration part up here to make sure you got that right?
Oh, yeah, it is e to the power of the equation.
Yeah, so that's actually who we want.
So
Probably multiply.
It does not.
No, it doesn't.
So, does it matter where you put the plus C, like can it go on both sides, or does it have to go on
Other,
the side?
it leaves
going
the
back?
absolute value.
It's a good question.
Point.
So the plus c can go technically anywhere. It's gonna be far easier to have it on that x. If you had the plus c next to the y, the plus c would not be part of the natural log. And so you couldn't do this method to be able to get y by itself. It may not seem like it's gonna be easier right here, but it actually will be. Okay, did anybody get to this stage? Do you want me to explain that stage?
Yes.
Okay. So there are two ways to view this. So I feel like most of the pre-calc teachers, the way that they taught you to solve a natural log was to take e to the power of both sides. Is that how they explained it to you? And it's not really wrong, it's just different than what I was taught. But if that's the case, e to the power of natural log, they cancel each other out. Because that's one of the properties. The way I was taught was different, but it's the exact same info. I was taught to just take it out of natural log form. So natural log form is the base e to this power is equal to that. So you end up with the exact same line written next anyway. Okay, but the important part here is that absolute value doesn't come off the y yet. And the reason I wanted to choose this example to solve for y is because the method that is traditionally used is not one that you would usually think of. So first of all, let me take off the absolute value. Do you guys remember how to take off an absolute value?
You have this value to the side.
No. It's not a bad thought, but no.
It works for most things.
It's the exact opposite.
You.
Because absolute value on one side means that the other side could be positive or negative.
Plus or minus.
Yeah. So what they taught you in Algebra 2 was taking off the absolute value symbol is gonna be plus or minus, which is correct. It's the same thing as doing square root of square root. But you can remove the absolute value symbol and have a plus or minus. Which normally we don't like doing because it creates more than one, creates multiple things. Okay, the portion of this that usually nobody would think of doing is the plus c. Most people aren't gonna see this in reverse. It's just like your brain doesn't like it. Do you guys remember, when you had two of the same base and different powers? How do you put them together?
Add them.
Okay, great. So you add their powers together. Over here, these powers are being added together. So like, instead of being written separate, they were combined. So this can be rewritten e to the 1/2 x squared times e to the c. Yeah, there's more steps.
Oh,
Yeah.
wait, we're still going.
Yeah, we're not done.
Oh, great.
Do you remember how basically any numeric operation on C just absorbs it? Like, we don't write 2C because we're just figuring out C later.
Oh, does it just become?
E to the C just becomes C. Because this is a number on its own, so rather than writing E to the C, making it look more complicated, you just write C. So this just becomes C. And then, the plus or minus are being multiplied times C, so it just sucks that up too.
So C just absorbs
C
every
is,
problem you have.
C is the all-powerful, being in math, apparently.
Ultimate simplification.
Yeah, just, I don't know how to do it, plus C.
Get rid of it.
I mean, it makes the arithmetic really easy, like, you don't have to figure it out, it just becomes part of it. And so this is the way the answer would actually be written. Oh my God. You know, it, as a teacher with a lot of years of practice, you would think I would learn how to talk and write right now, at the same time. It's not one of my skills, I guess. So this is the answer that would generally be written as a multiple choice answer. So if they ask you to find the general solution, it would be written like this, rather than this, even though these are both equivalent. This answer on free response would be totally acceptable. Multiple choice, this is the one you would see.
Wow, good point.
That was not a purposeful pun, but that worked out really well.
Could the, like, if you just have a negative to an equation, would they just get rid of that too? Like, just
Yep.
be, okay.
Yeah, like if this said negative y equals c e to the, then divided by the negative, it would just absorb it.
Are the AP tests like known to like write both answers and see if you
No, no, this is the one. So
Yes,
I'm
yes.
assuming,
Yeah, that's exactly what a monster is.
I'm assuming they prefer this format because when you have it solved for one variable, it's traditionally more convenient. Like say X stands for the amount of time. So like this is gonna be somewhat like our Newton's law of cooling formula we get, and or radioactive dating. These are essentially where these formulas come from. And so it's traditionally easier. Oh, PERT. Do you remember doing PERT?
Oh.
This is PERT.
What's
Compounded interest
Oh.
continuously. So like a 4% interest compounded continuously. They don't write it like this, they write it as P for principal, rate, and time. This is literally how they came up with the PERT formula. Okay,
Oh, I thought I'd never have to listen to that.
what? Now you seem like a genius because you can come up with PERT on your own.
Just by adding plus C to everything?
I mean, you're not wrong. I mean, it's not really right, but it's not really wrong. Okay, let's move on to step up the difficulty as we got. The difficulty is just that there's more parts, right? Try that one. See if you can come up with that one.
Check this out.
I have no idea if this one's gonna work out terrible or not. I like doing the problems with you guys.
So I'm done.
You can't just write C. I mean,
I thought you just switched it over, you're like, yeah, I'm done now.
I'm just C.
I mean, if you're really lost on a question, it's not a terrible plan, but I mean, it's,
Just write, you write random equation, you write plus C.
100% you should write plus C if you're integrated, even if you think you got it wrong, because you might
Just
get the point.
looking at this question is just, yeah.
What? Why?
I just needed a D, I just needed a DX and a DY.
It's just.
Prime is the same thing as dy dx. Zero? Well, just move over the 3 even there.
Yeah, so
Wait,
where am I finding?
Y
it?
prime is dy dx?
Correct.
Oh, wait,
I assumed it was just dy.
Oh wait, can I
How's
rewrite it
DX?
just for, just to see, can I rewrite it as
Wait, no,
DY?
dy dx.
So-
Wait, I'm stupid.
Y prime is a different style of notation that is equivalent to dy dx. So dy dx is preferred for this because of the way it's written, but prime is the same thing.
Okay. That hurt me.
We have to just keep going like the other one, or do we just?
I don't know. Is it gonna be solved for y very easily? Then you, so you solve for y if you can. That's usually the general rule of thumb. Come on. if y is
I've solved.
solvable, you do. If it's a y squared, you don't generally have to make it say y equals. Because the squared would make the answer plus or minus. And so they consider the plus or minus a worse answer than just y squared to start with.
I think our test.
You do?
I do.
Oh, well, that is one thought, not a great one, but it's one thought.
Great idea.
Oh, I mean, it would probably be great in terms of maybe your grade would be better, but then wouldn't I also make the test harder accordingly?
I don't know.
I think it's gonna be.
No, I definitely would, yeah, I definitely would.
But
Where's your?
I'm not forgetting anything, I know
Oh,
what
wait.
I'm missing.
Oh, wait, we forgot
I
something.
realized it a minute.
We forgot
No, it's up here, it's up here.
Oh, okay, well, I forgot. So I wrote it at the end of the equation.
What?
I just wrote it at the end of the equation because C can be written anywhere and it still works.
You only need one plus C,
It is yours.
This one didn't actually have a ton of work at the end, no. It's kind of it's your choice how you would want to solve it.
Oh crap, we did it.
Oh, back, do you want me to back up where I got an answer from?
We did it right, I just saw the bottom answer and I was confused.
So these are both equivalent. I couldn't tell you which one would be a multiple choice answer. It's also possible that they would subtract that to the left-hand side and make it say 2y squared minus 3 to the x equals c. I'm not the one writing the answer, so I don't know.
Why did you not like just go all the way for y and just add the
So the plus or minus is kind of, trying to think of a nice way to say it. No. There's a phrase for it, but I don't think there's a new phrase that is less. PC? I don't know the right way to say that. No, you can't pause it, which would be great, right?
Just say it.
Write it on
Just
the
copy
board.
it out, yeah.
Don't worry.
Oh, no, he can't, no,
It's
right on the
considered
right.
lower class.
Ah.
I'll put it that way. So plus and minus is considered lower class than y squared. So they usually will have the answer as y squared. Right.
So it's the same thing though, as just taking this right.
100%, they're the exact same answer. I can just tell you that after reading through the AP test for a lot of years, they don't do plus or minus, they don't like it, so,
Well, wouldn't it be absorbed by the plus C?
no.
No, it'd be outside.
Oh, it's outside, yeah.
It only absorbs it if it's directly on the plus C.
Oh.
Okay, what time do we get done, 6?
Which even if it were.
You won't get that one done in time.
Is that a
That's
challenge?
not what like.
Actually,
That's a
why
challenge.
don't we just, yeah, do this one, see if you can finish it before the end of the hour. I'll start putting the answer up in a minute. It's not like it's horrible, it's just got an extra step. Like you can't integrate the x's immediately. You guys had this exact same example in the homework and it, few people didn't quite catch on how to do it.
Oh, should we multiply?
Oh, I'm thinking of a different example, my bad.
Yeah, I was about to say.
Yeah, I was about to say that was easy.
I think it's on the next page.
This one's not.
Yep.
Yeah, this one's pretty easy.
Oh, God.
Were you doing
Three words.
Yeah, this one's not hard. Or it shouldn't be considered hard.
We literally just talked about it.
I don't
They
care.
don't do this.
I do. I have y equals.
Isn't that just it?
What is supposed to do?
You don't
Lindsay was correct on this one.
Really?
What? Wait, what did he say?
Yay.
Oh, cause yeah, it would be plus or minus, no, it would be plus or
He
minus.
said
Cube
something.
root is not plus or minus.
He said something short and I missed it,
Let's
dang it.
go.
I don't like it.
I could always just go back to the good old like, oh,
Square root gives you plus or minus, and odd root does not. An odd root can be either one.
So now we can take this cube root of both sides.
Yep, and so I will just say or, because I don't know which answer they would give you.
Yeah, that is.
There we go.
Boom. Easy clap.
Easy. No. Everyone.
Yeah, I'm definitely thinking of a different problem in the notes. There was a different one that had x plus 1 over x.
Wow, that's.
It's not terrible, it's just, I know it was in the homework previously,
There's one
and
that's
people got
x
stuck on it.
plus 1 over x y.
Yeah, that's the one I'm talking about, but the y won't be with it.
That sounds.
Okay, we'll stop here though.
That.
We got through one page, I'll consider that a win, because that's actually a decent one of our examples. For first day of learning a topic, that's pretty good.
Yeah, now